So we're going to go ahead and get started. I know the other class is still coming. Again, if you have any questions, we did put out some 3x5 cards. If you don't have one close to you, we got extras. Please, 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 if you have any questions, write them down, give them to us. We will either figure out the answer or find somebody who can. So this week we are doing cosmology, and when Ryan and I, astronomy, when we started talking about it, I started getting out my makeup. And he goes, "No, Mom, not cosmetology, cosmology." Oh, okay, I gotcha. So anyway, we're gonna watch a video that was done by Dr. Jason Lyle. He is a physicist, cosmologist. This is what he put together for the Answers Museum as one of their planetarium shows. So you can pretend you're laying back and looking at the ceiling as all of this is happening. So I guess we'll go ahead and get started then.
As we learn more about the universe, we are continually amazed at the astonishing diversity and beauty we find. Though marred by the curse, the universe still exhibits the handiwork of the Lord. By learning more about the intricacies of the celestial realm, we gain an infinitesimal glimpse into the infinite mind of God. One extraordinary aspect of creation is the incredible range of sizes and distances we observe. The International Space Station orbits approximately 200 miles above the surface of the Earth. This is far higher than any aircraft, and yet it really isn't very far into space. The Earth itself is nearly 8,000 miles in diameter, and yet the expanse beyond extends to distances that we cannot truly comprehend. The space station and other man-made satellites represent only the surface of a celestial ocean. The Apollo astronauts traversed a much greater distance. Traveling at the speed of a bullet, they took 3 days to reach the moon. The moon lies at an average distance of 240,000 miles from Earth. This is the farthest that human beings have traveled into space. Yet, the Earth's distance from the sun is 400 times greater. The Earth orbits at an average distance of 93 million miles from the sun. But the outer planets orbit at much greater distances. Neptune orbits 30 times farther from the sun than Earth does. The dwarf worlds Pluto and Eris are even farther out. Their orbits do not lie in the same plane as the planets. The orbits of all the planets could be contained in a cube that is 6 billion miles on a side. Yet, the distance to the stars is far greater. The next nearest star system is Alpha Centauri. How many solar systems would fit between the Sun and Alpha Centauri? The answer is an astonishing 4,278. It is a distance that is almost impossible to imagine. Upon our arrival, we can see that Alpha Centauri consists of more than one star. The combined light from these two stars appears as a single star in our night sky. Alpha Centauri A is the larger and brighter of these two stars. It is a glowing orb of hydrogen gas, very similar to the Sun, though slightly larger. Its surface temperature is around 6,000 degrees Celsius, the same as the Sun, and so it has a similar color. Alpha Centauri B is slightly smaller and cooler than the Sun. Alpha Centauri A and B orbit each other every 80 years. A third distant star of this system, called Proxima Centauri, is faintly visible. The constellations look very similar to the way they look from our solar system. This indicates that most bright stars are far more distant than Alpha Centauri. The Big Dipper is a familiar sight, and so is the constellation Cassiopeia, except there is now an extra star in this constellation. That is the Sun. As seen from Alpha Centauri, the Sun is just a bright star. The planets cannot be seen at all from this distance. As we journey back to the solar system, the constellations change only slightly. The Sun is over 100 times larger than Earth in diameter. And while most stars are smaller than this, some of the brighter stars in our night sky are considerably larger. Sirius is the brightest star in our nighttime sky. Sirius is bright because it is relatively nearby, a mere 50 trillion miles away. It is almost twice the diameter of the Sun. The light blue color indicates that Sirius has a surface temperature of around 9,000 degrees Celsius. So, blue stars are considerably hotter than the Sun, whereas red stars are cooler. Pollux is a member of the constellation Gemini. It is a giant star, nearly 10 times larger than the Sun in diameter. The constellation Orion is a familiar sight in our winter sky. It has a number of stars even larger than Pollux. The center star of Orion's belt is called Alnilam. It is a blue supergiant. 25 suns could be lined up across its disk. Blue stars like Alnilam are very luminous. They expend their fuel quickly and cannot last billions of years. So, blue stars remind us that the universe is much younger than is generally claimed. Secular astronomers are forced to assume that stars like Alnilam have spontaneously formed in the recent past. However, star formation is riddled with theoretical problems and has never been observed. Rigel is also a blue supergiant. It stretches nearly 70 suns across. As amazing as this seems, even larger stars have been discovered. Betelgeuse is one of the largest stars in the solar neighborhood. It is a red supergiant, even larger than Rigel. Betelgeuse is roughly 600 times the diameter of the Sun. If Betelgeuse were placed at the center of our solar system, we would be inside it. Betelgeuse would completely engulf the inner planets. The size of Betelgeuse pales in comparison to its distance from our planet. Astronomers often use the term light year when referring to stellar distances. A light year is a measure of distance, not time. 1 light year is roughly 6 trillion miles. Betelgeuse is over 400 light years away, or 2,400 trillion miles. Yet, it's one of the nearest of Orion's bright stars. Alnilam lies over 1,000 light years away. Now we will travel much deeper into space, several hundred light years toward Orion's belt. On our journey, we get a sense of the astonishing distance to these stars. The Hyades star cluster is visible on our right. We pass Bellatrix, the nearest of Orion's bright stars. Next out, Betelgeuse slowly drifts across the scene. A myriad of faint stars continually glides past our field of view. We are now roughly 400 light years away from home. As we pick up speed, we pass by Rigel and Saiph. Finally, we reach the nearest stars of Orion's belt. We have traveled a distance of 5 million billion miles into space. We glance back in the direction of the solar system. It is located here. However, the sun could not be seen from this distance without a telescope. It is a humbling experience to think of our entire solar system reduced to an invisible point. The constellations are completely unrecognizable from this distance. Although many of the same stars are visible, they no longer connect in a way that makes sense. Since we define the constellations as seen from our solar system, they point the way home. And as we travel back to the sun, they return to their familiar shapes. We now know that our sun is not the only system with planets. Astronomers have detected one or more planets around each one of the indicated stars. Several hundred extrasolar planets are now known to exist, and it seems likely that countless more remain undetected in the depths of space. In most cases, the planet itself cannot be seen directly. It is lost in the powerful glare of its host star. However, astronomers are able to measure the slight wobble the planet gravitationally induces on its star. This technique allows us to estimate the orbital period and minimum mass of the planet. In some rare cases, the planet passes directly in front of its star, as seen from Earth. The star V376 Pegasi has a planet that crosses its disk precisely every 3.52 days. Astronomers can measure the drop in the star's brightness and determine the size of the planet. Of course, this technique is only possible for the handful of star systems that are nearly edge-on relative to us. This planet is larger than Jupiter, but it orbits 20 times closer to its star than Earth orbits the Sun. This so-called hot Jupiter is a serious problem for secular models of planet formation. These scenarios had predicted that gas giants can only form far away from their parent star. Yet the vast majority of extrasolar planets so far detected are hot Jupiters. It's a difficult problem for secular notions, but not for biblical creation. Such diversity is what we would expect from the biblical God. This is the Upsilon Andromedae system. It has 3 known planets. All 3 are larger than Jupiter and orbit remarkably close to their star. The innermost planet is estimated to be 20 times larger than Earth in diameter. Its proximity to the star makes its temperature over 1100 degrees Celsius. Since current technology is not able to observe these worlds directly, we can only speculate what they look like. But we can be certain that their richness declares the majesty of their maker. In addition to stars and planets, the universe contains nebulae. A nebula is a cloud of hydrogen and helium gas spread over a vast region of space. Many nebulae are very hot and give off light. They are some of the most colorful objects in the cosmos. Some nebulae are relatively small, produced by the ejected gas of a single star. These are called planetary nebulae because many of them are round and appear like an out-of-focus planet. Planetary nebulae are quite common. Other nebulae are much larger, spanning many light years. These amazing creations can rightly be called the artwork of God. Our summer evening sky contains a number of other objects called globular clusters. They're too faint to be detected with the unaided eye, but are easily seen in binoculars or a small telescope. The globular cluster M4 is found just to the right of the red star Antares. Through binoculars, M4 appears as a faint, fuzzy blur. However, a telescope reveals that this blur is the combined light of thousands of stars. This is the most distant object we've visited so far. M4 is 7,000 light years away from Earth. That's 40 million billion miles. This globular cluster contains roughly 100,000 stars, yet it is only 50 light years across. This incredibly dense star field would be a wonderful sight. In addition to these countless stars, M4 also contains a strange object called a pulsar. It is thought to be the crushed core of an exploded star. Powerful beams of radiation emanate from the star's magnetic poles. When a beam sweeps past our field of view, we perceive a bright flash. However, if our solar system were not in the path of the radiation beams, we would not detect these pulses. By measuring the precise timing of these pulses, astronomers have learned that this pulsar is orbited by a planet. As with all extrasolar planets, we can only guess how this planet may appear. The view from this world must be absolutely breathtaking. On the other hand, it would be difficult to see beyond this bright star field. If we lived in a globular star cluster, we might never know about the vast universe beyond. M4 is merely one of more than 100 globular clusters that belong to our galaxy. This is our galaxy, the Milky Way. It spans 80,000 light years across and contains more than 100 billion stars. The Milky Way is a spiral galaxy. The brighter stars are concentrated into arms that wrap around the disk. Since our solar system is within this disk, we see the Milky Way as a cloudy band in our night sky. No human being or spacecraft has seen our galaxy from the outside, as shown here. It is difficult to grasp just how large our galaxy is. Our solar system is located here. In fact, with the exception of M4, all the stars and planets we've visited are within this little ring. The Milky Way is a remarkable demonstration of God's power. But what's even more amazing is that our galaxy is merely one of billions. Every one of these faint clouds is an entire galaxy. As we pan upward, we see a strange band where galaxies seem to be missing. This is called the zone of avoidance and is aligned with the disk of our galaxy. Although many galaxies are undoubtedly in this region, gas and dust in our own galaxy prevent us from seeing them. Further up, we see a massive grouping of galaxies called the Virgo cluster. It contains over 2,000 galaxies and is 50 million light years away from Earth. At the heart of the Virgo cluster lies the giant elliptical galaxy M87, which has over 1 trillion stars. Galaxies come in a variety of shapes and sizes. Each one is a glorious demonstration of God's limitless power. Critics of the Bible have suggested that it is impossible for the light from these galaxies to reach Earth in only 6,000 years. They claim that these galaxies prove the universe is billions of years old. But in fact, there are several different ways to get light to travel these distances in a short period of time. These include gravitational time dilation, alternate synchrony conventions, and others. In fact, spiral galaxies are a serious problem for the notion of billions of years. Their spiral arms contain vast numbers of blue stars, which cannot last billions of years. Also, spiral galaxies rotate differentially, meaning the inner portions rotate faster than the outer portions. So the spiral arms cannot last billions of years. They would be twisted beyond recognition, but it's not a problem for the biblical timescale. From the Virgo cluster, our entire galaxy appears as a grain of sand, lost in a vast ocean of galaxies. Yet the galaxies shown here are only a small portion of the cosmos. Beyond this distance, astronomers have cataloged only certain regions of the visible universe. At last, we begin to see the large-scale structure of the universe. The galaxies are organized into a complete tapestry of strings and voids. For clarity, only a few selected regions are shown here. This is the universe, or at least as much of it as our present understanding makes possible. Just imagine the power involved as all these galaxies leapt into existence at God's command. And yet the Bible describes the creation of all this with the single phrase, "He made the stars also." The psalmist writes, "When I consider your heavens, the work of your fingers, the moon and the stars, which you have ordained, what is man that you are mindful of him, and the Son of Man that you visit him?" We will now travel back home by zooming in by a factor of 10 every 4 seconds. The little circle is 10 times smaller than the large one. Every time we see a new circle, we've traveled 90% of the remaining distance home. The strings and voids of galaxies seem to disappear as we approach home. We plunge into the nearest several dozen galaxies, called the local group. The Milky Way becomes visible at last. We're approaching our galaxy from almost directly above. We enter the Milky Way between two of the spiral arms. We can now see that these arms are comprised of billions of stars. As we approach our solar system, the stars slow down and converge to their familiar positions. We pause briefly to note that we are now able to recognize the constellations. The sun is dead ahead, but from this distance it appears as a faint star. At last, we reach the solar system. The orbits of the outer planets are highlighted. We can now see the orbits of the inner planets, but the Earth itself is still invisible from this distance. The Earth may seem an insignificant speck compared to all that God created. Yet, this tiny world is where God placed the crowning jewels of his creation. Of all that the Lord created, human beings alone have the privilege of being made in God's own image. And though we have rebelled against our Creator, he's paid the penalty for our treason. It was on this small planet where the Creator of the universe became a man and died our death. He then rose again and has offered forgiveness for all who call upon his name. It is fitting that we should honor God for who he is and for what he has done.
Boys got up to fight. There we go. Okay. Howdy, everyone. So, part of the reason we wanted to show you that video was kind of to put things into perspective and scale. It can be very easy for us on Earth to forget just how big the universe actually is. And more than that, I think it can be very easy, because we are so earth-focused, so earth-centric, to make God a God of the earth and not a God of the universe. That when we are talking about God, we are not talking about a deity living in the sky and the clouds watching down on us. We're talking about a guy who sees the entire universe as just that thing in the palm of his hand. Like, that is how big of a God we are talking about. That being said, though, we need to talk about the elephant in the room. Okay. Oftentimes, when I will say exactly that, people will say, well, of course there's aliens in the universe, because how can a universe that is this big, this large, potentially infinite, not have additional life in it? Well, from an evolutionary perspective, the argument is valid, if not still very implausible. I will kindly remind you the reason why multiverse theory was invented in physics is because the probability of life starting on Earth was so infinitesimally small. The only way they could mathematically justify life existing was if there was an infinite amount of parallel universes. Surely one of them would have life on it. But let's look at this from a creation perspective. If God created, okay, if there is life in the universe, God had to create it. Okay, as Christians, as creationists, we accept this fact that the only way that there are aliens out there is because just like here on Earth, the God who created us also created them. Okay, so if that is true, when God created the alien lives, just like he created here, they would have been without sin. I think we can all agree, God does not create sinful creatures, meaning he cannot create, he is a perfect being, he is a perfect entity. He cannot create something that is in itself not perfect. And when God finished his creation at the end of day 6, he said it was very good. Okay? Things with sin cannot be very good. All right. The fall of Adam was not a global fall. It was a universal fall. There is not a distance we can get away from Earth. And it's like, if we can just get 20 million light years away from Earth, we'll get out of the fallen world and we'll be back into God's perfect universe. No, the fall was universal, which means Adam's sin caused the aliens to fall as well. When God made the second Garden of Eden on this other planet where they're living their peaceful lives and they're doing what God told them to do, God came down one day and said, sorry, I know you guys haven't done anything wrong, but this other people on this other planet that I made, they ate the apple, so you're going to die now. Tough luck. That also means, okay, we have to remember, when Jesus died on the cross, he died for all sin everywhere once and for all. He did not die multiple times. He did not die for only the people on earth. He died for the entire universe. Okay? And what was the point of Jesus' death? It was a reconciliation. It was to create a relationship between fallen man and God, the relationship that was destroyed in the fall, which means that Jesus' death for the aliens, he died for a race of life he never met and had no relationship with. This would be the same as if our Gospels taught, yeah, John the Baptist, he came along, he started preaching, and then one day he said, good news, on another planet, Jesus just died on a cross and we are now all saved. That's it? Like, where's the actual relationship? Where is the purpose of that? We would all agree that that's kind of anticlimactic. I mean, this universe has fallen, we've fallen into sin, we're struggling, and then somewhere, someplace that we'll never know of, we'll never see, we'll never talk to, God did something and now we're okay? That doesn't seem like the kind of God who wants to have that personal relationship with you, okay? So in conclusion, if there are aliens out there, they hate our guts. Because if God is true and all of this happened, this is how their true Christianity religion would go. God created us, we did nothing wrong, someone else, somewhere else messed up, and now we live in this sinful, broken world where people are dying, there's cancer, there's tornadoes, there's earthquakes, and they ruined everything. And they are out there somewhere. We can find them, and we can kill them. That is going to be their thinking. So, yes, I hold to the belief there are no aliens because that is what helps me sleep at night. Because if there are aliens and God is true, then they are on the warpath seeking us to destroy us. Happy thoughts. Okay, so now we're going to get more. That's the theological, okay? I can't give you necessarily a scientific breakdown on aliens, but theologically, I am pretty sound in the fact probably no aliens. But now we're going to get into the scientific stuff. And I warn you now, astronomy is a dense subject. I'm going to be giving Cliff Notes versions, and if you get lost, yeah. If you have a question, if I say something and you don't understand, or if you're like, hey, wait a second, what about this thing? Put that hand up there. Second off, if this is like, I wonder about these things, that's what the note card is for. Go ahead, write it down, and not next week, but the next week after that is going to be our wrap-up week, and we'll answer any lingering questions that exist. But, so first, this was slightly talked about in the film that we just watched, the light and time problem. The argument goes something like this. Hey, we see this star. It's 48 million light years away. You say the Earth is only 6,000 years. How can something that takes 48 million years reach here in 6,000? Okay? Logically, you find, sure. Here's the problem with that. First, a light year is not a measurement of time, but of distance. I hate the fact that they named it a light year. I get it. It is saying that in a year's time, this is how far light travels. But is it really? And what I mean by that is time is relative. And what I mean by that? It is relative to the speed of which it is going and the gravity of which a person is in. Which means that in a year on Earth is not a year in other places. So for light to travel a year from Earth's perspective, it could actually go further than what we would consider the distance of a light year, or less, depending on the time dilation. And that's a lot of words to say, we do not truly understand how time functions outside of our solar system. Why? Because we've never been outside of our solar system to test time dilation and how it works. As well as we do not truly understand how light functions outside of our solar system, for the exact same reasons. We know light is a constant in that if given the exact same parameters and functions, light will always do exactly the same thing. The problem is we don't know what the parameters are outside of our solar system. Now, this is a concept a lot of people struggle with. Space is a fabric. It's not empty nothingness. It is an actual, tangible fabric that we cannot touch. Okay. Think of it like it is a giant blanket that has been just spread across, which, does kind of give a little bit of a different understanding of when the psalmist says the hands that stretch the heavens. Is the hands literally stretching the heavens? But the point of that is, how does gravity work? Okay, so you have this big, huge blanket. If the sun is a marble, and you drop the marble onto that blanket, it creates a little bit of a dip. That is what is referred to as a gravity well. Okay? The deeper that well gets, the stronger gravity becomes. Right? And so how orbits work, if I get it, there we go, is a smaller marble gets caught in that dip of the bigger marble, and as it's spinning, it just catches and it just keeps going around and around, which is why you tend to have the smaller stuff gets closer to the center and the larger stuff is further out, because you would otherwise have collisions and stuff happening in your solar system. But all of that is to say, so this is what a gravity well looks like from going straight on. So the further down you go, the slower time becomes relative to the rest of the universe. What I mean by that is that on the surface, on the top of this, time would relatively be moving faster than the further down you go. And that little red ring is what is referred to as the event horizon. And the idea is that anything past that point, for all intents and purposes, time has stopped. Okay? That if you get below that point, time moves for everything else, but you come back to here 2 billion years later, time has not moved any. Now, it has been theorized, not necessarily proven in any way, shape, or form, but one of the possible solutions to the light-time problem is during creation, if Earth is the center, if the Milky Way is the center of the universe, because God started here and built out from it, then what you would have is you would have a very large gravity well in the universe, and the Earth would be at the center of that. So it would be the furthest down. It would be the furthest down here, while everything else was higher up. So time would be moving faster the higher up you go, as opposed to the Earth, where time is moving slower. So that would mean that because time is moving faster up here, the light is moving faster because it travels based upon time. I say all of this, and because if you are lost and if you're like, wow, I don't get this, he's talking way over my head, congratulations, you have now reached 90% of astronomers who this is their profession. Okay? This is such a dense and complex understanding that most people cannot fathom, cannot comprehend time dilation. And to put this all in a bit of a point, okay. So, galaxies, despite the fact that they don't look like it, they are moving. They spin. Okay? And they are also moving away from each other. It's the expanse of the universe. Okay? Galaxies move. That also means our sun is moving. As the spiral arms are traveling around, our sun is one of those little dots in the spiral arms, and our planets are caught up in the gravitational pull of the sun. So as the sun is shooting through space, so are all the planets. I say this to emphasize the speed of the star affects the time that we understand. Okay? What I mean is as the star is shooting through the universe, that speed causes time dilation. The size of the star causes time dilation. The bigger the star, the further down you go in to that gravity well, and the slower time becomes. The size of the planet affects time dilation for the exact same reasons. Also, how fast the planet is spinning on its axis affects time dilation. How fast the planet is moving around the star affects time dilation. The size of the galaxy affects time dilation. To say that that galaxy is 400 million light years away, therefore it takes 400 million years for that light to get here is ridiculous. Okay. We do not know how long it actually takes for the light to get from there to here because we do not know what the time dilation is from there to there. And that's just one thing we don't know. Here's another thing. We don't know how light travels through space. Yes, we think of lights as lasers that just go in a straight line, but actually light is closer to water. It takes the path of least resistance. Perfect example of this, when you're drinking your coffee next time, when you pull out your mug and you look down there, you'll see a nice little ring of light on the bottom of your mug. But it's not a perfect ring. It kind of bends on one point and kind of makes it more of an oval than a ring. Well, what's happening? Well, as light is hitting the coffee mug, it's taking the path of least resistance, and instead of making a perfect circle, it just kind of bends on itself. Okay? Now imagine that, but in space, over billions and billions and billions and billions of light years, and all of a sudden, light will do some weird stuff that we don't understand. Okay. Oh, last one. And the position of the galaxy affects time. And I say this, or the position in the galaxy. I say this because the closer you get to the center of the galaxy, the more dense the gravitational field becomes. The further away from the center of the galaxy, the less the gravitational field becomes. Because what's holding the galaxy together is a very dense core of gravity. We don't know if it's stars, we don't know if it's black holes, we don't necessarily know exactly what's at the center of a galaxy, but we know that the mass and the gravitational pull is massive there. Okay. To wrap this part up, the Bible was written in the perspective of time on earth. When it says God created in 6 days, it means he created 6 days relative to the time on earth. Meaning, it could be 6 days here on earth, but it was 1,000 years at Alpha Centauri. Okay? It could be 1,000,000 years in Alpha Centauri. We don't know what the time perspective was outside because it was all written, this was the time here on earth. When we say the universe is 6,000 years old, what we mean is according to the perspective of the time of Earth, 6,000 years ago is when God created it. However, if you were made on another galaxy in another planet, it might not be 6,000 years. It might be longer. It might be shorter. On some planets, they could be days after the creation because time is just moving so slow. Or it could be millions of years. We don't have any kind of strong, ooh, it's this or that. I'm going to finish this with dark matter. And I do this I'm not going to go into depth about dark matter, but I want to explain the origin of dark matter, okay? Late 1800s, early 1900s. We're starting to get pretty powerful telescopes, and for the first time, we're starting to be able to see other galaxies. Okay, we look at these galaxies and we see that they're spirals and that they're spinning, and we're relatively able to guess the way, how fast they're spinning. And they go, that's weird. We know the universe is billions and trillions of years old. These galaxies look way too young. They should be like falling apart if they were that old. by the way that they're spinning? Well, clearly, because we know the universe is billions and trillions of years old, there must be a gravitational force keeping these galaxies together that we just can't see, detect, or have ever even experienced before. And we'll call that dark matter. Dark matter kind of became mainstream in the 1930s. The concept was around before that, but it was in the 1930s that the scientific community was really like, okay, we have to answer this question. Because it appeared to be younger than it was, there must be a form of matter that cannot be seen, touched, measured, tested, or detected by humans. There has to be, because we know the universe is this old. This matter must make up over 80% of the universe. I have seen papers that say it makes up to 98% of the universe. Okay? Think about that for a second. Over 80% of the entire existence cannot be observed in any way, shape, or form, according to evolutionists. And where did this concept come from? Because it has to be. We know it has to be. We know this thing has to exist because if it doesn't exist, everything we know is wrong. And creationists are called the unscientific ones for believing in something they cannot see, hear, touch, or experiment with. I mean, truly comprehend that. To be an evolutionist in any field requires far more faith in the unknown, in the unnatural, in the unexplained than being a Christian. Like, which one is really the one of unbelievability? And also remember, according to evolutionists, the entire universe came by chance. It just happened to happen. That's miracle one. Okay? Miracle two, completely unattached to miracle one, but had to happen in this order, is that life also exists. Okay? You can have the universe and not have life. You can't have life without the universe. So you had to have a miracle of the universe existing. Then you had to have the miracle of life existing. But not just any life. You know, we're not talking about protozoa or cells. We're talking about real complex life. That's miracle three, intelligence. Okay? Again, you can have organisms but not have intelligence. And how does intelligence come from just living material? Don't know. It just happened. Okay? So, to be an evolutionist requires three miracles. To be a creationist requires one, the existence of God. I say it's a miracle. I'm going to end it. This one, yeah. Well, okay. I was going to, but now that I said that. So this was a question that was proposed to us before. The question was if we had ever heard of Barry Stedfield, and more importantly, the zero-point energy and the changing of the speed of light over time. To give it a real quick summary, he was basically looking and he said, hey, you know, when you go back in time, the measurement of the speed of light was faster than it currently is now. So maybe what that means is that the speed of light has actually been decreasing over time. Well, I had heard of Barry, but I didn't really know anything of his work, so we sent this question off to Danny Faulkner, who was the astronomer who was at church a while ago, and I'm just going to read to you his answer, because what he says is going to carry far more weight than anything I'm going to say. I am not convinced that his idea that the speed of light has changed throughout time is correct. First, I don't think the data supports it. The most important points that trend Barry claims to see is the historical measurements of the speed of light are the earliest ones, but those are the measurements of the speed of light that were subject to the greatest error. In astronomy, we often use error bars to graphically express the uncertain measurements of uncertain measurements. If that is done with the historical data of the speed of light, I can draw a horizontal line through the data, indicating the speed of light is in fact constant. That is, I think Barry is seeing a trend in the data that does not exist. My second objection to the change of speed of light is that the speed of light is not a fundamental constant. The speed of light depends upon two fundamental constants, permeability and permittivity of free space. Those constants determine the strength of electric and magnetic effects, such as the force holding atoms and molecules together. If the speed of light changed even a little, the structure of matter would change a lot. We do not observe this in the universe, so that is a strong evidence that the speed of light does not change. But Barry thinks he has found a way around this, zero-point energy. Barry believes that zero-point energy can account for the speed of light change over time by adjusting the other effects I just mentioned so that they do not change while the speed of light does. That strikes me as very convenient. Zero-point energy is controversial topics in physics. It is controversial. It derives from quantum field theory. It is the notion that there is the lowest possible state of space itself. The reason that it is controversial is that it makes predictions that are at odds with many orders of magnitude with what we see in the universe. Until these many issues are explained, zero-point energy exists in the realm of speculation. I have other problems with what Barry suggests. It is very tidy that the effects of the changing of the speed of light can be hidden so well, but also the change in the speed of light seems to have ceased. Barry thinks that the change in the speed of light was exponential, and like other exponential decays, it flattened out to a constant about the time man developed technology to measure the speed of light very precisely. That seems very convenient. What I take from that is he's saying there's two main problems. One, it's amazing that the speed of light became constant about the time that we were getting instruments to accurately measure the speed of light. Two, the idea of zero-point energy I find is a lot like dark matter. I have this theory, but it doesn't work with what we see, therefore I'm going to create a fictional form of matter to explain how my theory does make sense. We can't test this matter, we can't see this matter, we can't interact with this matter, but it has to exist. Again, not a whole lot of what we will say data-driven to back it up. Now, this picture is a picture from the Voyager. Oh, can we dim the lights just a teeny bit? This is a picture from the Voyager probe. Now, I assume most of you know what it is, but if you don't know, during the space race with the Russians, we sent out probes. And the purpose of the Voyager probe was to go all the way across our solar system and take pictures of every single one of our planets. It's where we get most of our close-ups of the planets. But due to the coolness of space, they don't stop when they reach the end of the solar system. They kept going. And so just as they reached the edge of our solar system, it turned around and it took this picture. This is the picture of our solar system, as seen from the edge of space. Now, you might not be able to really see it, but right there is a pale blue dot. That is Earth. And I say this for many reasons. One, it's really cool that Earth is caught up in a sunbeam like that, almost as if the Earth has the light of God shining down on Earth right there. But I also think it needs to be humbling for us. We can get so big in our heads, we can get so big in what we think of ourselves, who we think of ourselves. But all of your problems boil down to a pale blue dot in the emptiness and existence of the universe. And I will add, if we are a cosmic accident, that is the most disheartening thing you can possibly imagine. But if we are the created beings of a God, we are the most important thing. We are not but a speck in the universe. If we did not exist, the universe would not care. But to God, we are the most important thing in that universe. Okay, so that's it for me. I know that was a lot. We can bring the lights back up now. We've got a little bit of time left. Anybody got any questions? Anyone got any like, hey, wait a second, that doesn't make sense? Or, hey, what about this? Yes?
Are there mainstream scientists that, to bring, have a discussion, or they just shut down and they don't get tenure and they don't get hired at universities?
Okay.
Are there people that are somewhat vocal out there that says we don't know?
Yeah. So for the audio recording, she's asking, are there secular mainstream scientists that are trying to have this discussion, or is this just getting shut down in every way, shape, and form? The answer is yes and no. So of all people, Ben Stein did a movie a while back called Expelled that was just cataloging several instances of, again, mainstream, not Christians, not creationists, just saying, hey, this thing called evolution doesn't actually add up, and how their life was destroyed for saying that. That being said, and in fact, we were going to talk about this on week 6, but I will mention it now. There is a group in secular science, it is called the Third Way. And this is scientists who are saying, hey, we're not Christians, we don't believe in God, we don't believe in creation, but looking at this evolution thing doesn't actually work. So that must mean that there has to be a third way. We don't know what that third way is. We don't know how it would work. We don't know, what it would look like, but it has to be there. Because again, it can't be God, but it can't be evolution either. So again, yes, there are people who are questioning, but yes, the scientific community is very quick to shut any of that down. Because you mentioned that, I don't have it, but there was a Chinese paper that was published in an American journal. So it was translated from Chinese to English. And in that translation, it made mention of a creator. The scientific backlash to that. Yeah.
Called it the divine footprint.
Okay, the divine footprint, yeah. They're just talking about, hey, when we look at this, they were not actually meaning a divine footprint in that God's footprint design on, it was just a mistranslation, essentially. That paper was pulled from the scientific journal that it was written in. Because the very idea of a divine footprint is so unscientific that they pulled the paper. Again, atheists who weren't meaning that mistranslated, or had a mistranslation, had the entire scientific community up in arms. So yeah, most scientists, even if they do have problems with that kind of, maybe there is something more to this, they will keep it to themselves. Okay, anything else? No? Well, next week, we're going to be talking about biology, which is just as in-depth of a field. I find it interesting, or we'll say coincidental, that starting from Earth, whether you get smaller or you get bigger, it doesn't matter, it gets more complex. Which, to me, does not scream accident. To me, that screams somebody made it. Thank you all for coming. I'll see you guys next week.